So we are now going to deal with rotary motion, rotational motion, not curvilinear this time, not linear, rotary motion. That motions, that what happens when things are rotating, wheels, rotating motors, whatever that rotates. Now let us look at a problem. Let us think of a problem. The first question says that a wheel of a vehicle rotated from rest. It rotated from rest. That means initial velocity is 0. Rotated from rest with uniform acceleration in 12 seconds of rotation. It rotated, the wheel of a vehicle rotated from rest within a uniform acceleration. In 12 seconds, it rotated its rotation. In 12 seconds of rotation, a point is in 12 seconds of rotation in a point or at a point on the wheel has a velocity of 24 meters per second. In 12 seconds, as it's rotating, in 12 seconds, it rotated up a velocity of 24 meters per second. 24 meters per second. If the wheel is 1.8 meters in diameter, if it's 1.8 meters in diameter, that means it will be, this radius will be 0.9 meters. 1.8 meters in diameter. This radius will be 0.9 meters. Calculate the angular velocity and the angular acceleration of the wheel. Calculate the angular velocity and the angular acceleration of the wheel. Also find the normal and the tangential acceleration. So to start with, since it started from rest, angular velocity as we know would be velocity over r. From here, angular velocity is equal to tangential velocity over r, which is in this case, angular velocity is equal to 24 over 0.9. That is over 24, that's over r, which in this case we got to be 26.67, which is equal to 26.67 meters per second. This is the angular velocity. So with this angular velocity now, we come to angular acceleration. Angular acceleration is angular velocity divided by time. That means angular acceleration. Angular acceleration will be angular velocity, which is 26.67 over, over time this time, not over the radius. So, and the time this time is 12 seconds. It's 12 seconds. That means 12 over 12. 12 seconds, which I got to be equal to, is equal to 2.22 meters, 2.22 meters per second squared. That is the angular acceleration. Now to get the normal acceleration, v squared over r, normal acceleration, which will be v squared over r, which v was 24. 24 squared over 0.9. As simple as that. 24 squared over 0.9, which I got to be 640 meters per second squared. 640 meters per second squared. That is the normal acceleration as needed from the question. So now we have from tangential acceleration, we have tangential acceleration, which is 24. The tangential acceleration is equal to the velocity. Tangential acceleration is equal to velocity over time, which in this case is 24 meters per second over time of 12, which is equal to 2 meters per second squared. Which is equal to 2 meters per second squared. And that is what that's what the question demanded. The question says, the wheel of a vehicle rotated from rest with uniform acceleration. In 12 seconds, that's the time of rotation on a point, the wheel has a velocity of 24 meters per second. If the wheel is 1.8 meters in diameter, calculate the angular velocity, which we calculated. Look at the angular velocity. Calculate the angular velocity. That's what the question says. Calculate the angular velocity and the angular acceleration, which will be calculated, the angular acceleration, the angular velocity, the angular acceleration. Also find the normal and tangential acceleration. Normal acceleration and tangential. Look at normal acceleration and tangential acceleration. Look at normal acceleration, v squared over r. And tangential acceleration. We also get the tangential acceleration at the end of the 12 seconds. And that's what is on the board. The wheel of a vehicle rotated from rest with uniform acceleration in 12 seconds of rotation on a point on the wheel has a velocity of 24 meters per second. If the wheel is 1.8 meters in diameter, calculate the angular velocity, angular acceleration of the wheel. Also find the normal and tangential acceleration of the wheel at the end of the 12 seconds. That is, and that's what is on the board. We'll be able to solve that. Thank you very much.